Welcome to your first MP5 Honors video. I will not play it back to hear myself. So, we are going to begin by evaluating using trigonometric identities. These are some trigonometric identities. Stands for the sine, cosine, tangent. This is the cosecant, secant, and cotangent. Essentially, these two lines say that the sine and the cosecant are reciprocals of one another. So, for example, if the sine is 1/2, the cosecant, if the sine is 1/2, the cosecant would be the reciprocal of that, or 2/1, plain 2. So the cosine and the secant are reciprocals. So if the cosine were 1/2, the secant would be 2. Tangent and cotangent are reciprocals. Tangent is 1/2. Cotangent would be 2/1. It's important for me, I have to memorize all of these, so how do I do that? Tangent and cotangent clearly go together, and most things in math seem to be the opposite. So logically, sine should go with secant, but no, it goes with cosecant, and cosine goes with secant. And then you just need to remember that they are reciprocals of one another. Oftentimes what we're going to be asked to do is to, given two trigonometric values, we're going to ask find all the others. So you need to make sure you know the sine, cosine, tangent, cosecant, secant, and cotangent. So the first thing that I always start out with is the Ferris wheel unit circle. When I have the Ferris wheel unit circle, I got to figure out which quadrant this angle is in. Remember, this is the tangent of an angle and the cosine of an angle. I can put a reference angle in one of the 4 quadrants, but I need to figure out which quadrant I'm in. So your high dive experience is going to come back to you. The sine of a function, remember, deals with the height of the Ferris wheel's person, so the height of the diver at any given moment. This over here is the ground. So then you got to think about, okay, up here in the first quadrant, the guy's above the ground, the sine is positive. Second quadrant, this guy's above the ground, sine is positive. Third and fourth, it's negative. So let's go on to cosine. The cosine deals with the left-right position of the diver in regards to the center of the Ferris wheel, which is right here. So over here in the first and fourth quadrants, the cosine is a positive because he's to the right. And in the second and third quadrants, it's negative because he is to the left. You need to remember from Imp 4 that the tangent is equal to the sine over the cosine. Oh, wait! What does that tell you about cotangent if it's the reciprocal? That must mean it is cosine over sine. Just a little note. Anyways, I'm going to erase that for now, but tangent is sine over cosine. The tangent, thus, has to be positive in the first quadrant because it's a positive over a positive. Second quadrant, my tangent is a negative. And third quadrant, it's a positive because a negative over a negative is a positive. And the tangent in the fourth quadrant is a negative because a negative over a positive is a negative. So let's look back at our current problem. Our current problem says the tan of x is equal to the positive, that value, this value here, sorry, I'm pointing with my finger, which you cannot see, and the cosine is equal to a negative. So if the tangent is positive and the cosine is negative, that puts me into the third quadrant. I like to, at that point, draw myself a unit circle, little sketch. I know that my x value, reference angle, is right here. So this is x, which is really small. Okay. And now I just need to find all the other trig values. Well, some of the easiest ones to find are the reciprocals of the tangent and the cosine. So let's do those. If you, sorry, I got to get down to my pulley thing. Knowing the cosine, what can you easily find? You can easily find the secant because they're reciprocals. Therefore, the secant is equal to the reciprocal of the cosine, or 2 over root 3. The sign goes with it. So this will also be a negative. Negatives can be written in the numerator, denominator, or just out front. You should recall that that looks really ugly. You may not leave radicals in the denominator. So therefore, I need to rationalize the denominator. When you multiply the top and the bottom by the square root of 3, your numerator becomes 2 root 3, and your denominator becomes root 9. Root 9 is the same thing as 3, because the square root of 9 is 3. So therefore, this is the value of my secant, which was some awesome circling. So now we're going to go down to, which other one can I find easily? Well, if you know tangent, you can easily find the cotangent because they are reciprocals of one another. So the cotangent is going to be the reciprocal of what you had before. If you look up top, which I'll show you, tangent is root 3 over 3. It's a positive. So cotangent is 3 over root 3. Now you need to recall that you may not leave it in this format. You need to rationalize the denominator. So I'm going to divide both sides by, multiply both sides by root 3. And I end up with 3 root 3 over 9, root 9, which is essentially 3. You also need to look because these two will cancel, they will reduce. Remember, you cannot simplify under the radical with the denominator. So then my answer is root 3. Double checking. Yep, this is a positive and mine is a positive. 2 trig functions to go. The last 2 trig functions I have are the sine and the cosecant. Next thing I do is I label my triangle. Cosine, go back to basics, is adjacent over hypotenuse. That was awesome writing. Looking here, this is my adjacent side, so this is root 3. Notice how that is a negative root 3 because it's to the left, negative x values, over my hypotenuse, which is 2. I steer away from labeling my tangent values because they tend to get a little more confusing. Notice that my hypotenuse opposite over adjacent, sometimes it works, sometimes it doesn't, so unless you have to, just ignore the tangent for now. Because right here I have a right triangle and I know 2 sides. I can use the good old Pythag to find the third side. So negative root 3 squared plus something squared equals 2 squared. This is where I'm going to run into problems with this video. It's hard to write. I'll get better, I promise. So negative root 3 squared is actually 3 plus x squared equals 2 squared, which is 4. So x squared equals 1, therefore x equals 1. So I know this is 1. I need to look at that quadrant. That's the third quadrant. This is a negative y value, so it's a negative 1. So far, so good. Notice how this will help you with your tangent because it's opposite over adjacent. Negative over negative is a positive. 1 over root 3. You would rationalize the denominator, and you get exactly what you had up here in the tangent. So it all works out, but labeling using the tangent actually is far more confusing. So now I can easily find my sine value. So my sine value is going to be opposite over hypotenuse, which is negative 1 over 2. So my cosecant value is going to be the reciprocal of that, which would just be negative 2. So that is your first introduction on how to find all the other trig values. But maybe I just found out, I thought I only had 10 minutes on this video, ends up I have 15, so I am now going to scroll on down for you and do another example, because one example will not suffice. I was going to make a separate video, but don't want to cut my time short. Here we are. We have the cosecant of theta is 5/3 and the tangent of theta is 3 over 4. And I need to find all the other trig values. So I'm going to write the answers on the side. I'll switch up colors in case you're sick of that ugly color there. So here we go. We're going to start with, well, if I know cosecant, what can I easily find? So I know the cosecant, which I'm just going to write right over on this side so that we're more organized. Again, you know in class I would be far more detailed and write it out in a nice list for you if I could write quickly. So I know cosecant. What can I easily find if I know cosecant? Well, that's sine. They're just reciprocals. So the sine is 3/5. If I know tangent is 3/4, what can I easily find? Well, that would be the cotangent. The reciprocal, which would be 4/3. Now I just need two trig functions left, cosine and secant. I got to think back. I go positive sine, positive tangent. What quadrant am I in? So positive sine, positive tangent. Only place how that happens is the first quadrant. So I will now draw a rough sketch of my right triangle. Here we are. I use the fact that my sine is opposite over hypotenuse. So this would be 3/5. Remember, I ignore my tangent values. Just because sometimes it works out, but sometimes it doesn't. And I can always use the Pythagorean theorem. A squared plus b squared equals c squared. So 3 squared, which is 9, plus x squared equals 25. Now I can solve for x squared by subtracting 9 from both sides. X squared equals 16. So therefore, if x squared equals 16, x equals 4. 16, x equals 4. So since x equals 4, I can label it here. Please watch your signs. You got to make sure, should this be a positive? Yes, it should be, because this is the positive x-axis, given the location of my triangle. Notice how tangent here makes perfect sense. Opposite over adjacent, 3/4. Now I'm going to switch colors so my numbers don't blend for you. I can easily find the cosine, because cosine is adjacent over hypotenuse. So this is 4/5. If I know the cosine, I just need to flip it to get the secant, which would be 5/4. Voila! All right, it's 12 minutes. Let's see if I can get one more in. It says try on your own. So why don't you take a brief moment and try it on your own, and then we'll come back to you and I will have some answers filled in. All right, so welcome back. See if your answers match mine. Root 10 over 10, negative root 3, negative 3 root 10 over 10, and negative 1/3. Root 10, negative, I forgot that, root 10 over 3 and negative 3. Make sure your signs match up like I did not. Positives, negatives, negatives. So now to walk through my steps, when I knew the purple ones, which were given, this purple and this purple, I could easily find the reciprocals. You might be like, I didn't get root 10. Well, because I actually got 10 over root 10 for the cosecant. I rationalized. I multiplied by root 10 over root 10 and got 10 root 10 over 10. 10's canceled, root 10. From there I said, well, I need a unit circle. So I said, what quadrant is tangent negative and sine positive? That would be the second quadrant. Drew my little triangle. Here's my x. I labeled my sine opposite over hypotenuse. I ignored my tangent. Then what I did is I did some little Pythag. 10 plus x squared equals 100. So x would equal the square root of 90. And I said that's 3 root 10. Some of you might go, what? Well, root 90 is root 9 times root 10. The square root of 9 is 3. 3 times root 10. That goes back to your imp2 experience. And Dubé's built it best. For a second there I forgot the negative, but I quickly added it in because this is my x values are negative over here. So then notice that your tangent will work out because it's opposite over adjacent. So this and the root 10s would cancel out and you'd have 1 over negative 3, which is your tangent. With 1 minute left, I then flip this thing around to get my secant. You might not have gotten that if you got that far, but I had 10 over 3 root 10. I rationalized. My thumb is starting to hurt from this mouse, so I said I'm multiplying numerator and denominator by root 10. 10 root 10 over 30. Then the reducing makes it root 10 over 3. And then make sure it's a negative because the cosine is a negative. And that is your first video, as well as mine. Oops, I gotta pause it.